And welcome back. So we're going to try something slightly different this week. I'm going to show you the opening questions that my further maths group, so my new further maths lower sixth set, the questions are designed just to test the basics. So to be clear, these are not designed to be super hard questions to check they're capable, but just show that these are all the absolute basics we assume before we go through the course. The way I'm going to do it today, just because the questions are a little bit quicker than normal, I'm going to do 2 per day, and the final 2 questions this week are definitely going to be a bit more challenging. But either way, as I say, all skills that you need at minimum to be able to get through the further maths course pretty easily. So let's get started. As ever, pause the video, have a go at this one. I'll come to it in a second. Okay, so we have here a transformations question, and I ask this because I know a lot of students don't like transformations, which is why I've got it here. We do teach it in a slightly different way further maths. So we teach it in a way which checks that you understand the transformation both in the X and the Y, and actually a bit later on in the Z direction as well. But this is a pretty standard GCSE one, so I'm going to use GCSE techniques. The second question I do, by the way, I'm going to do the further maths style. So how would I approach this question? So again, teachers do teach this in different ways, but the first thing I would do is I'll observe the question says the magic word sketch. So therefore I don't need to be super precise. I don't need to draw it on the same diagram. I don't need to copy it over and measure exact numbers. I just need to have a sketch that has the right shape. The next thing I'd notice is there are some key points on this chart. So the points are 0, 1, 1, 1, which is a sort of cuspy point, and 3, 0. So those are the points I need to reflect when doing my sketch. If this were a real exam question, it'd make it a bit clearer what it wants you to do. Now let's look at question 1. Now again, this is very much the way that I teach it. Other teachers teach it differently. I just think this is quite a neat way of doing it. So I'm thinking this is half x inside the bracket. So that means I'm going to do the opposite to the x value. So I get my lot to write down something like this. It's obviously not good maths literally, but what it's saying is take all the x values and multiply by 2 and leave all the y values alone. And then I can just go all through the x values. So 0 times 2 is 2, and 1 times 2 is 2, and 3 times 2 is 6. And the y values stay all the same. So that's going to give me this shape here. Notably, the same shape, just stretched in the x direction, which is the definition of this transformation. First one done. Next one. So this one is, well, it's a bit easy to explain because I'm multiplying by 3 after I've worked out the value of f of x. So in other words, all my y values are going to be 3 times larger. So again, using the mathematically incorrect, but still slightly helpful way of remembering it, my x values stay the same, my y values are all 3 times larger. So the 1 becomes a 3, the 1 becomes a 3, the 0 stays a 0 because 0 times 3 is still 0. So therefore I get this shape here. Now note what I've done. I've pretty much drawn the same sketch twice. I just have different values on the sketch. Because again, the word sketch does not imply completely correctly ratioed diagram. You just have to be careful you're drawing the right sort of shape. The next one's actually quite similar. So it says -2. So I'm going to work out my f values. I'm going to take them all to be positive to negative and negative to positive, make them all twice as big. So 1 becomes -2. So let's just go here. So this 1 at the intersection becomes -2 on the other side. 1 becomes -2, 0 stays to 0. In other words, it's a reflection in the x-axis and an expansion or an enlargement in the y direction. So we'll look at, again, something like this. First question done. Not too bad, but equally a weakness of many GCSE students. Often marks lost here. Next question. Okay, so seemingly a very similar question, but the reason I've chosen this one is it allows us to think a little bit about the sort of ways we're going to teach in further maths. And again, some of you might have learnt this way already, and to be frank, I don't know why we don't teach this at GCSE because it's a slightly neater way of doing it. So think about what's happening. I've got the graph of y equals x cubed. As we know, that's a cubic shape, goes upwards on the right and comes down on the left. And then I'm translating it by -1, 4. So in other words, if I move the graph, my new x values are going to be 1 to the left, and my new y values are going to be 4 upwards. So in other words, I've reflected this -1, 4 in terms of new x values and new y values based on the original values I had. So what I could then do is rearrange this equation so I get the old x value in terms of the new x value. So in other words, I've got x equals new x plus 1 and y equals new y minus 4. You'll notice this is why when we say it's inside the bracket, it does the opposite. This is where it comes from. Now, how's that helped me? Well, the reason that's helped me is I can take my x and y here and I can substitute it into the original equation I'm given. So let's do that now. So y equals x cubed is going to be y minus 4. Again, I'm substituting these terms here. You'll notice the dashes or the apostrophes are missing, and that is because I don't need to show them anymore, because now I'm just working in new xy space. So you could keep them there, but I'm going to have to remove them later anyway. Now, I'm just going to do this next step in one go. You will learn binomial expansion. Some of you may have seen it before. If you do GCSE further maths, you will have seen it during GCSE further maths. Either way, check that you're happy that you can get to the same point, which is going to be y minus 4 equals x cubed plus 3x squared plus 3x plus 1. And I can do that in one go. Now, y minus 4 on the left-hand side, add 4 to both sides. That gives me the equation I want. And then I'm going to put a little square at the end that just tells me that I've proven it fully. Now, again, in a real question, it'll be a bit clearer exactly what it wants you to do, but I'm pretty confident, I'm pretty happy I've shown this is the case. That's it. First 2 questions done. Different set of questions tomorrow. As ever, do like the video, please subscribe to the channel and ask any comments below. Thanks all.